All right, guys, welcome to the sum of a finite arithmetic sequence. If we don't have a calculator and we have to do this by hand, no big deal unless we have 1,000 terms, in which case then we luckily have a formula. The formula is easy enough to understand its derivation, so let's take a shot at it. Before I actually derive the formula, let me show you something kind of basic and simple. If I, let's say, have 1, 2, 3, 4, 5, I could write 1 plus 2 plus 3 plus 4 plus 5. That's 15, right? If I want to show that sum, I could go backwards too. I could say 5 plus 4 plus 3 plus 2 plus 1, also 15. I'm showing this to you numerically first because if you understand this numerically, you'll understand why this works algebraically. If I were to take these and add them, well, that's obvious. That's 30, right? So that's really 2 times 15. But what's interesting here on the left side is that you'll have 1 plus 5 is 6, 2 plus 4, right? I'm adding all I can, whoops, fix that. I can add all these up. 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. I'm going to constantly get 6. And how many 6s do I get? Well, how many terms did I do? 1, 2, 3, 4, 5, right? So I could say this is 5 times 6. But either way, you can tell that it adds up and there's these nice little patterns that form. And the second thing is when you add something up, even if it's in reverse order, if the total is 15, you're just doubling it. So with this part and this part, those two things we just talked about, we can follow that pattern algebraically and derive this formula and this formula. So let's get to it. So I'm going to rewrite this. Whoops. I'm going to rewrite our series using the definition of a arithmetic sequence first, okay? And what I mean by that is instead of writing a sub 1 and a sub 2, I'll write a sub 1 and then I'll define a sub 2 using a sub 1 and the common difference and so forth. So let's do that. So if I have a series from 1 to n for a sub k, the first value is a sub 1 because k is 1 on the bottom, right? And the last value is a sub n. So if I wanted to write a series, I'd be adding then a sub 2 and a sub 3 and so forth. Instead of writing a sub 2, I'm going to say, hey, it's my first term plus the common difference, because that'd be my second term. So it would be a plus 1, a sub 1 plus d. And if I want to write my third term, it would be a sub 1 plus 2d, right? Because it would be plus the common difference again. And I can keep doing this until I get to the last term, which would be represented by a sub n. Oh, wait, but this, I want to write it as a definition of a sequence with common difference. So this one would be a sub 1 plus, again, now how many common difference do I add? I add n minus 1 d's. So that was all from the last section. Now, if I want to write this backwards, well, this part would still be written the same way, the sigma notation. But instead of starting with a sub 1, right, like over here, whoops, right over here, I started with the last number. So in this case, the last number would be written as a sub n. And then the next number after that, going backwards, would be a sub n minus d, right? Because you're going down by the common difference. And then a sub n minus 2d plus, and then now you're going the other way, you're going to a sub n minus 1d, right? This is just going backwards. Instead of starting from the first value and adding up, you're starting from the last value and subtracting down. Now we're going to do the same exact thing as last time. We're going to combine them vertically. Now if I combine this vertically, I know, right, this and this is like saying, hey, each one of these totals 15. This would represent the total, just like 15 represents the total. So if I have two series here and here defined by k is equal to 1 to n of a sub k, I would just say, oh, well, I have two of those, so it's 2 of these, two of these summations. And here's where this part is kind of cool. So a sub 1, a sub n, that would just add up. A sub 1, a sub n add up. But then the minus d plus d, the minus 2d plus 2d, and the minus n minus 1 plus n minus 1, those will all cancel out nicely. So cancels, right? And we're going to be left with a bunch of a sub 1 plus a sub n's. Well, how many of those do I have? Just like over here, right? No matter how I added, I got a bunch of 6s. How many of them do I have? I have 5 because I had 5 terms in that sequence or in that series. So in this case, how many terms do I have? I have n terms. So then that'd be n times that. And then at the end of the day, if I want to get this definition, then I could divide both sides by 2, and I will get summation from 1 to n raised to k equals n times a sub 1 over 2. Now, the way they wrote it, they have the 2 in there, so I'll write it actually. So divided by 2, it doesn't actually matter. That's just kind of a nicer way to show it. But you can have the entire thing over 2 or n over 2. And that's the derivation. Now, the last part, notice we have 2 formulas. Notice this formula looks a little different, so I'll show you how they got that formula. So instead of writing a sub n, so this is one formula, right? But the second formula just takes a sub 1, or sorry, a sub n, and it says, well, again, from 9.3, that's really just a sub 1 plus n minus 1 times d. If you just substitute that in for a sub n, so you're going to do a substitution, and then you pull the 2. So instead of saying it's a sub 1 plus a sub n divided by 2, they just write n over 2. So they're going to plug that in. So again, of a sub k. So they're going to say it's n over 2, which is convenient. And then now it's a sub 1 plus, and instead of saying a sub n, that piece over there, they're going to substitute that with this. And that's a sub 1 plus n minus 1 times d. And if you simplify that, you'll get 2 a sub 1's plus n minus 1 d. And so that is your other formula. And so either of these formulas could be used. One of the formulas could be used if you would choose to use the first formula if you had the first term and the last term and the number of terms you're looking for, or you would use the second one if you had the common difference there and not the last term, right? So you would use each formula appropriately to whatever givens you have. All right, let's move on to example 1 after this.